So our opinion, our point of view is that the computational intensity of FEA has led to all sorts of limitations in how it's used. Okay? So if you're trying to use FEA early in the design process, it's a real pain because if you're trying to do detailed simulations of a large system, it's very, very slow. Okay? So the way people traditionally get around this with FEA is they either do detailed analysis of small parts of an overall system, or they do very, very coarse analysis of the overall system. But there's no ability to combine those two together and provide detailed analysis of the whole system. So that's what we enable. We enable fast, detailed analysis of large systems because we have RB FEA. And the other key point is our models are parameterized. Okay? So they're built up of components, and each component has parameters in it. So what that means is you can click on a component in the XLS graphical user interface and you can change a number like the length or the density or the stiffness or the Poisson ratio or the curvature of a component. You can change its geometric or its material properties. And what this means is it's very easy to update an XLS model of a system. And that's extremely valuable when it comes to iterative design. You have a basic idea of what your system should look like, but you want to simulate it hundreds or thousands of times to hone in on what a better design is. And this should really be done early in the design process. But with FEA, it's basically computationally intractable to do that, because to modify a model, if you modify it, you then have to go through the whole FEA solve all over again, which is 1,000 times or more slower than our solve. So the approach we provide is to set up a component-based model and then go through iterative design, optimization once the model is set up, and that can really help to hone in on good designs much more efficiently than with a conventional FEA. So basically it boils down to workflow constraints with the conventional approach. And then in terms of can this speed up that we provide also benefit in the post-deployment phase? Absolutely. That's actually where we're currently focused. We see upfront design, using our software in the upfront design phase, as extremely interesting and beneficial, and we've worked with customers to use it in that fashion. But we're also very focused on the post-deployment phase, where we provide, or a company creates its own XLS digital twin of a physical asset that has been deployed. And the key thing about an XLS digital twin, again, is that assets are deployed for decades. And over the lifetime of the asset, it will change. It will get corrosion, it will get damage. If you're talking about offshore structures, sometimes a ship will bump into one of the pylons and it will get bent. You want to be able to easily update your model so that it incorporates all of those changes that are happening over the lifetime of the asset. And anytime there's a change, you rerun 1,000 simulations on it, and all the different scenarios you're worried about, a storm, big waves, all these kinds of different things. You simulate all these different scenarios, and then you understand if the current state of the asset is safe, or if you need remedial action, you need maintenance and these kinds of things. And going further with that, what we're very focused on at the moment, we have a major R&D, European R&D grant for focusing on at the moment, is incorporating these digital twins, the XLS parameterized RBFEA digital twins with sensor data. So the idea, of course, is that many assets already, critical assets already have sensors on them, accelerometers, strain gauges, these kinds of things. They're internet connected, so Industry 4.0, Internet of Things, these kinds of things, these concepts play very nicely into what we're focusing on, because there's many sensors out there, they're internet connected. This data can be fed into our cloud-based servers that host our digital twins, and the digital twins can be automatically calibrated based on that sensor data. So the idea is to have a real-time updating digital twin that takes into account any significant changes in your physical asset, and then you can run analysis on the updated, calibrated digital twin, and then obviously understand any risks and have very good intelligence about what you should do about these risks.